All right, give it just a few more seconds. All right, welcome everyone to the weekly SIG-Apps meeting, where we talk about all things about running applications inside of Kubernetes. This week, we have Chris Love, who's going to give us a demo of a 1,000 node Cassandra cluster. I look forward to that. And then we'll have some open discussion, and also we'll fit in a little bit about analysis of the poll that we did a few weeks ago. So with that, Chris, hello.
Good morning, everybody, or afternoon, whichever time zone you're in.
Yeah. So the floor is yours.
Thank you. Appreciate you guys making the time to join us. This demo was part of a presentation that was co-presented with Google and I at the Red Hat convention that occurred last week. They were kind enough to allow me to play within Google Cloud and spin up 1,009 nodes of Kubernetes. And let me just go through a quick presentation, then go on to the demo. And let me see if I can share my screen. So the main feature that we're showing off within Cassandra or within Kubernetes 1.3 is pet sets. We're also using jobs and resource controllers and a bunch of other components. Can everybody see the presentation?
Yes, we can.
Awesome. Just a little bit of background, why we chose the Greek pet races. Most of everybody that's on the call should know that Kubernetes is actually ancient Greek. It means helmsman or pilot. I'll breeze through these slides here. Cassandra also is the daughter of Troy through Greek mythology. She's the daughter of King of Priam and the Queen Habuku of Troy. I'm sure I'm massacring that Greek name. Cassandra is a big data database. It's fault-tolerant, decentralized, durable, supports multiple physical and regional data center replication. Pretty easy to scale horizontally and vertical, and it's backed by data stacks. Here's my obligatory big data slide. One of the things I want to mention about Cassandra, just in passing, is that deployments on cloud or on machine is all about the disk. Patrick McFadden is a chief evangelist for Apache Cassandra at DataStax. It's a pretty cool title. Basically, he's saying one of the biggest predictors of success or failure with Cassandra deployment is the choice of storage, and I just can't overemphasize that. If you're running it on cloud, you need to be on local SSD, or we haven't tested the performance of attached SSD, but that's what we're running in Google Cloud. So first off, please interrupt me throughout this presentation if you guys have any questions. Also, the reason that PetSet was developed is a good analogy to describe it. Is that you got a bunch of pets. You got a brown, black, and a white dog. The brown dog runs away. I have on the slide dies. I need to change that. It's kind of bad. You replace it with another brown dog and nobody would notice. But if you suddenly have 3 white dogs, somebody's going to notice. And that's the whole idea of identity within an application. Specifically, clustered and distributed apps are notorious for having to have such identities as DNS, storage, etc. PetSets is responsible for creating and maintaining a specific set of identities of pods, 0 or more supporting resources, as well as scaling that installation. As I was mentioning, it provides stable network identity through DNS, no duplicate identities, provides ordinal deployment. And what I mean by that is 0, 1, 2, 3, 4. You're going to tag the name of those servers as well as deploy your first Cassandra server at 0, second 1, 2, 3, 4, as well as Cassandra-1 that pod is always going to have the same stable storage. If it goes down, if it comes back up, it's going to be reattached with that storage. One thing with empty dir, of course, is going to wipe that, but that's pretty much the same as usual. So let's look at a bit of code here. I'm going to take it out of the presentation and take it on a GitHub. It's pretty to show services and stuff like that. So let me make this a bit bigger. In order to have network identity within a pet set, you have to have a service. This service is called a headless service, and you'll notice that it'll basically create the names of Cassandra-data-0 will be your first pod, and it'll count up from that, 0 to how many ever you want. This is the new feature that they're talking about. PetSet gives you the capability, or this is a YAML file that is I've reduced the size of the file. I'll actually provide a link to actual files that have been tested on the deployment. This provides, of course, the kind is PetSet. You set, just like as in an RC, you set the replica count. It'll deploy in order 0, 1, 2, 3, 4 replicas of this specific pods that we're about to define here. Of course, this is spec. If folks are familiar with Kubernetes, very much the same as every other spec. We have some environment variables that are specific to the Docker that we've built, which we're actually going to push back into the examples for Kubernetes. Unfortunately, haven't had the time to do that. Basically, you set your max heap size, Cassandra's Java application, new heap size. The interesting thing is the seeds, is what I want you to take a look at. With such components as resource controllers, the pod names are random. It's some naming convention that somebody came up with. With pet sets within the service, you'll be able to look up Cassandra-0.cassandra.default.service, blah, blah, blah. So it's guaranteed once the first 2 pods spin up, you're going to have these 2 lookup pods. Within Cassandra, in order to find quorum and get the topography of what's called a ring, it needs to know 2 or more nodes that are seeds. We have some other Cassandra stuff in here where we actually set up a data center, 2 data centers within a physical data center. It's one of the patterns used within Cassandra is to set up rings of Cassandra instances that are specific for workloads. And just some other stuff. We have a ready probe. The other thing that I wanted to point out is we now have automatically created PVCs and PV for storage. This is another alpha component within the 1.3 release. Basically, you denote what your volume claim should be, the size. It then will go and create attached storage for your persistent storage within your cloud if it's supported. At this point, one of the limitations of Cassandra is it doesn't have storage class capability. That's actually one of the PR or one of the design components that's going into the next release. And with that, you'll be able to specify, say, SSD storage or another type of storage class for Cassandra. So at this point, I don't recommend using the volume claim templates simply because you'll get slow storage, and Cassandra doesn't like slow storage. But in the future, you should be able to use these. You're able to use the volume claim templates as usual if you create your own storage points, and the deployment will automatically pick those up. The configuration I actually recommend is using empty dir and using local SSD on your node itself. That's probably the most performant that you'll get specifically in the cloud, and recommended by folks at DataStack. Any questions about the YAML that we have here, and specifically what a pet set is and how it impacts your deployments? All right, cool. Well, moving on. So this is a demo, so guess what? I woke up this morning and realized that it went down from 498 instances that were happy to 490. Now, you're probably going on, well, Chris, you said 1,000. Yes, I said 1,000, but this UI is specifically connected to the analytics ring. We've got two rings. Literally think of a hula hoop. We've got two hula hoops of Cassandra nodes that are 500 each, and I'll show it to you on command line in a bit. But what's happened is we've lost some of the nodes on the analytics side. Now, the nice thing about Cassandra, I could go down to 333, or actually 200. You can lose a third of those nodes, so whatever a third of 500 is, and still maintain data integrity. I know that there's some issues with storage. We are actually running this on a 1.3 beta with some modifications in it to get everything happy. There's some fixes for storage that went into the release, 1.3 release, and I know that's been having some havoc with our pods. What you're seeing here is basically we're running races. We're gathering data points, we're gathering normals, which are randomly generated data of the races. We have different types of monsters, and you can see basically we just did a pretty graph box graph of the different quarters, outliers, etc. Just general statistics through D3. So a couple of the interesting things with the numbers. Everybody's been kind of, let me get to the right screen here. Been kind of astonished by this. We used 8,072 nodes for this demo. Or I'm sorry, CPUs for this demo. We're currently using 1,006 IP addresses. I think we're at 1,006 nodes right now. I think I took down a couple. 1,011 routes were created. A couple weren't tore down when nodes came down. And where's storage at? There we go. So here's the regular persistent disk on GCE. We're using 100,000 gigabytes of that. And then we have SSD persistent storage, which is 380,000. So I gave approximately 380 gigs to each node, which is actually a pretty good value to be running Cassandra. You want to run around 500 to 750 max per node. Once you get to that point, you just add another node in your ring. We used an ingress controller for networking. You notice that was a public IP up there. Let's see if I can get to the right screen here. One of the new features, and this is specific to Google Cloud, is backend services, and you're actually able to see traffic flow and where the traffic flow is actually heading to. All of my traffic's been going to US Central 1A. We used Kubernetes Lite to deploy across 4 different availability zones. You can do this both in EC2 as well as Google Cloud. So not only is the cluster, so we have one master, but the rest of our nodes are spread across 3 availability zones. So God forbid, if you do have problems with an AZ, your nodes will shift to, the load will shift to the other AZs. So let's take a look at command line, what's going on a bit, and run another job. So in terms of technology, we have we had to get data into the cluster. So we created jobs to do that, which are a batch feature of Kubernetes. Our JHipster UI, JHipster is a Java tool we use to generate the UI, is hosted in a resource controller. One of the funny stories for this demo, putting it up, is with an ingress controller, you're going to get health checks. I had my resource controller up with 2 pods, turned on health checks with an ingress, and quickly it gave me 1,000 health checks coming in the door and took down my pods. Needless to say, I've got more pods running now. So you're able to see the job history. Let me go up in command line here, of the jobs that ran. And then we're going to run a new job that hasn't been run yet. If I find my command line where I can just switch out to horses. We have different monsters that we included in a data set that's all pre-populated in Cassandra. One of the monsters, really not a monster, but we threw it in there anyways, was horses. This is just simply a shell script that calls Kubernetes. It dynamically generates a job with metadata in it that's specific to the job that we're going to run. So you can actually see the YAML that was just generated. You can go back and take a look at our jobs. Fingers crossed. Seeing horses. It's been up for 7 seconds, so I'm not expecting any to be successful yet. Let's take a look at logs to make sure everything's happy. I assume it is. Actually, I think some are done now. We've had a couple of pods that were created and ran. So we got 2 that are through the gate. We just put in some timers. We've got a couple timeouts happening, so the demo gremlins are at work. We'll see if we get some data coming through. Most likely Cassandra is happy. So we've got 160 races running, or have been run. And we now have 164 that ran. Yay. And you'll also notice that we now have horses are popping up in our bar graphs. So we've run all these different types of monsters against each other in a race. So talking about pet sets some more, and let me take the demo or the sharing off here. Or actually here's another thing that might interest you. Wrote a little script showing the various pods up. And this is just calling kube control with some bash. Notice all the different data pods that are up. So we created 2 different Cassandra data centers. One is called Cassandra Data, which you're seeing all the pods running. You notice a restart there. Been a couple of pods that have automatically been restarted. And we created a data center called Cassandra Analytics. And you'll notice all the pods that are currently running in that. And you'll notice that 112 really didn't like me. I'm going to look at this with some of the engineers at Google to figure out how to deal with this, but that was actually user error. And of course, we got the rest. So currently, we've got only, so this is how we've lost some pods. We've actually had some issues recreating storage. So the pet sets are currently not running at 500. Curious why. One thing to note is that pet set, if you do a kube control get, the audio completes there. Well, you'll notice that pet set's not there. They chose, because it's an all alpha command to not put pet set in there. So current is 500, but you notice our pod count doesn't match that. And the same thing applies. You can do a get, you can do a scribe. And it would help if I put in pet set. So we have 497 running. So most likely we've had issues. Actually, I know why. I know why I didn't deploy. We're actually ran into a real nice bug that's been fixed. We're actually running out of log space on the master, and most likely that's why they didn't redeploy again. So couple of the use cases that are nice with pet sets are big data applications like Cassandra. Kafka is another ingress application. Apache Storm really likes when its identity is straightened out. Zookeeper is another one, not necessarily big data. This also applies to clustering RDBMS databases such as Postgres and MySQL that are picky about the storage that they're connected to, depending on the pattern that you use to cluster those technologies. HA proxy is another one that needs to know the identities beforehand so that it can proxy correctly. We're at about 10:22. I could keep on talking here and go through some of the project. What specifically like the jobs and the RC controller that are created. Really like to give it over to the floor, see what questions you guys have about why you'd run PetSet or anything else about the demo.
Yeah, does anybody have any questions about the demo? Thank you for the demo. This helped me visualize pet sets a little bit more since I haven't had much time to look at them. Do we have any questions from the floor? Silence. All right.
It must have been a great presentation then. That's all I have to say.
You explained yourself well, and so I don't actually have any questions either. So if you want, maybe if you have something else, take a few more minutes. Otherwise, we can switch to the next topic.
Yeah, absolutely. We have an hour set out, right? Maybe
half an hour. So there's only 7 minutes left for.
And you had some stuff to go over as well.
We got maybe 5 minutes worth of stuff.
Perfect. Then I'll just go over the project real quick. This project was set up, the Great Pet Monster Race and also K8S for Greeks was set up specifically for doing demos for Kubernetes. Just some overlay of the project structure real quick. You'll notice a DevOps folder. That's where all my DevOps stuff is at. One of the things I did write was a nice bash script for deploying multiple AZs on GCE. The Docker that you want to play with, if you want to play with the Docker, is the Cassandra Debian. Docker is actually going to be pushed up to the Kubernetes project. I'm going to update the examples that are in there. The jobs, real simple Python code. If you're interested in looking at the DataStax Python driver, really good there. UI was generated with JHipster. If you guys do any Java development in-house, it's a really good program that uses Yeoman to generate a project, a starting place for you to start in the project. Cassandra is one of the data stores that they support. Great. Well, I really appreciate your time. I can stop talking now. I'm available at Chris Loves CNM on Twitter, which is part of the meeting invite. Also on GitHub, it's on the same handle. If you guys have any questions, please holler.
All right. Thank you very much for the demo. And so with that, I'll move to a quick update on analysis of the poll data, which is something that I just have not had a chance to do this week. So I'm looking forward to probably starting that tomorrow. One person has responded and offered to help me analyze it. If there's anybody else who's interested, I'll fire off another email to the group to see if there's anybody else. Otherwise, I'll probably reach out to that person and start digging in Friday sometime, given the schedule. So look forward to that. Other than that, do we have any, this is open discussion. Is there anything on the floor anybody wants to talk about? I guess silence means we don't have anything. So with that, Chris, if you had anything else to put in the last 5 minutes or 4 minutes now.
Why don't we give folks back 4 minutes of their life?
All right. Everyone, you've got a few minutes back. Thank you for the time, and thank you for a good demo. That was well done. Thank you very much. And next week, we'll be back here with another one, show. We've got one next week, I believe, even though it's GopherCon, and so all the Gophers may be gone, but it'll be recorded.
Excellent. Thanks, guys.
All right.